This program is made possible by a grant from the National Science Foundation, a co-production by Mississippi Public Broadcasting and the University of Southern Mississippi Gulf Coast Research Laboratory. April 20th, 2010. 41 miles offshore in the Gulf of Mexico, BP's Deepwater Horizon drilling unit exploded after high-pressure methane gas engulfed the rig and exploded. 11 people would lose their lives that night. For nearly 3 months, oil gushed into the Gulf of Mexico. Marine life, tourism, and petroleum operations will never be the same in the Gulf region. Now there are questions that have scientists focusing on trying to shed light on the unknown long-term effects on the Gulf. This is the Science of the Spill.
Hello and welcome to the Science of the Spill. I'm Erin Pickens.
And I'm Dr. Bob Thomas, Director of the Center for Environmental Communication at Loyola University.
Now, the Science of the Spill is produced by the University of Southern Mississippi Gulf Coast Research Laboratory and Mississippi Public Broadcasting to inform the public with scientifically proven facts concerning the BP Deepwater Horizon oil spill.
We're going to bring together scientists that are studying this disaster for informative discussion to give the facts about issues related to the Deepwater Horizon oil spill. We also want to let you know you can find more on our companion website at spillscience.com. There you can find in-depth information about topics related to the spill, as well as video discussions from scientists studying the effects of the spill in the Gulf of Mexico. You may also want to join the discussion on our blog section of the site, where you can engage in discussions with scientists studying the impacts from the Deepwater Horizon oil spill. Again, that's spillscience.com.
A Mississippi Public Broadcasting crew traveled out to Cat Island and both East and West Ship Islands recently to document what effects are being seen on the islands today, 7 months after the blowout of the Deepwater Horizon rig.
With respect to the oil spill incident, these islands did serve as the first line of defense, albeit in a different perspective than what's usually referred to within more of a storm context. In many respects, there was a parallel to what occurred in the oil spill incident, in that the oil stranding or oil on the beach that first occurred happened on the barrier islands, and one could say as a result of that it either dissipated or reduced the level of oiling that otherwise may have occurred on the mainland and reduced the amount of oil that otherwise would have gone into the sound, where we have very sensitive seagrass beds that give rise to fisheries and other sensitivities within the bays.
Okay, well, we're on the southeast side of Cat Island, on the west side of Smuggler's Cove, out here with all this beautiful marsh back here. So one of the things that we're hoping to try to see is if there is any evidence of where oil washed up into the marsh in these areas behind us during high tides, and if it was deposited there. Because that's what we see on the beach over on the western side is the deposits of those asphaltenes, that what they call pepper here, those little tar patties all over the beach. And you would find something different in the marsh here.
Removal of oil began almost right after the inception of the incident. There was some delay from the time of the blowout until we began to experience oil on the shoreline, but within approximately 40 days we began to see oil in earnest across all of our shoreline areas in both Mississippi and Florida.
On all of these islands, the BP cleanup activities have been centered around using people with scoops, these little nets that they sift through the sand, or using some sort of a mechanized piece of machinery to do it, and they use two. On Horn Island, they have these very large sand machines like they use on beaches everywhere that scoops up, cleans the top few inches of sand, those tar patties, and here they have a specially designed for this beach little, it looks like a lawnmower that you walk behind. That's a smaller version that scoops up the first top couple of inches, sifts the sand through, and those little tar patties are left on that screen, and then they bag them up and take them away. What needs to be kept in mind when you come out here is that Ship Island has some unusual sand deposits here that have some different component minerals in it, ilmenite and tourmaline, that makes it look kind of like oil. And you see that in my hand here is the naturally occurring sand deposits that, while looking more like oil than the actual oil does, are actually a natural occurrence, the oil being part of the man-made event. So there's two different black constituents on the surface here. One, this naturally occurring sand, and the other, this oil patties from the BP event.
When an incident such as the Deepwater Horizon oil spill occurs, it certainly causes one to pause and take a moment of concern. What is going to be the ultimate effect on these islands? We really did not know. I know I had horrors of going anywhere in the park, whether it be in Mississippi and Florida, on the south shoreline, looking east, looking west, and seeing nothing but a tar mat of oil. That did not occur, which is fortunate, but we still have significant oiling and impacts that have occurred to our shoreline. So we're looking at it very keenly to make sure that we respond appropriately and long-term do everything feasibly possible from a management perspective to make sure these systems function as intended and that we do not interfere with them to cause any more harm.
Now, while the Barrier Islands off Mississippi's coast served as the first line of defense in the oil spill of 2010, crews continue hard work to clean the islands of oil. Now, let's hear from our panelists about the effects of oil on the islands and other parts of our coastal ecology.
We'd like to welcome our two guests today. First is Dr. Jesse Kassler, who's a research associate at the Gulf Coast Research Lab and University of Southern Mississippi. Jesse is a coastal scientist and an educator. Second is Dr. Ed Overton, who is Professor Emeritus of Environmental Sciences at Louisiana State University, and he is a oil chemistry expert. And we're looking forward to his comments. Welcome.
Thank you.
With us. Good. Well, Jesse, coming from off that video here where they talked about the Barrier Islands, there were two different types of machines used out there. Why is that?
Well, I don't exactly know, just to be clear about this, but we did find different machines on Horn Island versus Cat Island. And my sense, and this is actually what I studied, I'm a sedimentologist, but I think that the reasoning is just as simple as it could be related to the animals that live there, and they don't want to disturb the habitat. I don't think that's what it is. I think it's archaeological artifacts, which I know were found on Ship Island. And so they have that sort of rototiller-looking machine that they use to clean up in that area, and it doesn't go below 6 inches, and so it doesn't disturb buried archaeological artifacts.
Now, the video showed sand that looks oily but does not contain oil. It looks like you brought some samples here to show us exactly what is oil and what is not.
Absolutely. And we have two examples of oiled sand. One of them is relatively fresh. It's from September, early September, and those are clearly oily. There's oil in this sand. It's all the same sand all the way through, all collected from our Mississippi Barrier Islands. The second plate has more weathered samples of oil, and that's what they were picking up on Cat Island the day that we went out there. It was in November. However, what Chris Snyder on the interview was talking about was the presence of some heavy minerals, and they're heavier and because they have iron and things like that in them, and that is what you see over there is the normal sand that doesn't have a lot exactly of that ilmenite in it, but you get concentrations when the wind is moving at a certain velocity that makes for big deposits of these black sands, and people see them buried and they're not oil.
Wow. Okay.
Well, Ed, I know that running an oil lab at LSU, you've been sort of the go-to scientist when people are reporting what they call oil on the beaches or oil in the water. Tell us some of your stories. What kind of things are people bringing in for you to examine?
Well, with a spill where you have 200 million gallons of oil, the natural event is to say anything you see in the environment is associated with oil. And the truth is that there's a lot of things out there that are just naturally occurring, such as this black sand. So that should be there. It's been there. But when you compare it to white sand, you know oil's dark black color. You think, my gosh, this is contamination. what we have to remember is that oil, as it moves into the coastal areas, oil tends to glob to itself. It doesn't like to dissolve in the water, but it sticks to itself. So when it gets on shore, you find it in clumps such as these tar balls here. The clumps of oil, sand particles stick to the outside of the clumps of oil, so they look a little bit different, but they would not evenly cover the beaches such as we see with this dark sand. That's not oil samples at all. Lots of algal blooms associated with this time of the year, and people look down and they see something strange in the water, discolored water, and they say, my gosh, it's dispersed oil. Not dispersed oil. It's biological events that have been there for millions of years. It's just we're now starting to look, and we know in the background that there's a large oil spill offshore. So.
Well, when these oil spills happen, it's not just something happening in a vacuum. I mean, there's already a microbial fauna out there that lives off, gets its energy from oil. And I think the public who we're speaking to here has probably been surprised by some of the images they've seen when they report it as oil, and they say, well, that just looked like orange stuff floating on the surface. Tell us a little bit about that, about how it looks.
Okay, well, when oil comes out of the ground, particularly for this well, it's got a lot of gas in it. So the first thing that happens is that gas dissolves and effervesces away and breaks up the oil, a lot of the oil, into really, really tiny droplets. And those droplets stay down in the deep water. So that's oil that has been dispersed at depth. Some of the oil comes out as big globs, and it kind of floats to the surface, and it gets there fairly quickly. And there's the difference between the big globs and the oil that's so small that it can't rise to the surface. That oil comes up to the surface fairly slowly, and it interacts with water. It mixes with water, and so you see these different colored, we call them mousse. A mousse is a combination of oil and water. It's an emulsion. It's a stable emulsion. It's a mixture, much like mayonnaise, that involves oil components and water components, and they take on different colors depending on how much sunlight they've been exposed to and a variety of other incidents. So what we see is, in this case, there's 7 or 8 different appearances to the oil, all the way from a liquid material down to tar balls, which we see here on the table.
Yeah, and I know that some of the times that people are reporting what they consider to be oil because it's the color of the mousse and seems from a helicopter to be the consistency of the mousse, turns out to be algae.
Absolutely. Algae, the first reports we ever got were this peat material washing up on Chandelier Islands, and everybody said, look at this dispersed oil. It was not dispersed oil. It was a biological event. When they brought it to the lab, we put it through tests that can very definitively tell whether it's from petroleum or not, and these were not samples of oil at all. So,
right.
Mother Nature has many different forms in the environment, and in this case, we've got oil on top of all of these forms. So when we see some of these strange events, we say, oh my gosh, look at all the oil. In fact, that's not the oil. Oil has a very specific consistency. The tar balls are kind of the end of the regime. Oil comes out, and it's a liquid material. It mixes with the mousse and becomes pretty viscous, and ultimately breaks apart into these tar balls, and these are what are washing ashore on the barrier islands. Some of the coastal marshes actually got some pretty liquid oil, but it wasn't fresh oil. Fresh oil is the dangerous kind. All oil, it would be better if it were not on the beaches and on the coastal marshes. But it's a much worse situation when the oil is fresh. That is, it has a lot of the light components, the volatile components that can dissolve down in the water column, cause damage. So fortunately, in this spill, most of the oil that hit the shorelines was either weathered oil or in this relatively benign form called tar balls. Right.